In this video, we're going to determine the nuclide symbol from our given information. In this case, we're going to use our protons, neutrons, and electrons. So let's start with an example where we have some protons. Let's say that we have 72. We have neutrons, which is going to be equal to 115. And then some electrons, which will also be equal to 72. So first, we need to determine which element we are working with. And we can do that from our protons, because this is going to be equal to our atomic number. So looking at our periodic table, we're going to look for element number 72, which happens to be hafnium, HF. So let's put our HF right over here. That 72 is also going to be the lower number of the two on our atomic symbol. So we're going to put a 72 right there. Next, we need to determine our top number. To do that, we're going to take our protons and add those to our neutrons. That's going to be P plus N is then equal to that upper number. So we're going to take our 72 plus our 115, and that's going to be equal to 187. So that top number turns into 187. Finally, we need to determine if this element has a charge to it. The way that we do that is we're going to compare our protons and our neutrons, because our protons have a positive charge and our electrons have a negative charge. So we're going to look at our number. So our protons is equal to 72, which is also equal to our electrons. Because they equal one another, we know that this element is going to be neutral or have no charge. So we won't put any positive or negative symbols there, which means that this is our final answer. 187 over 72 HF. Let's try another example. So in this case, we're going to have our protons are just going to be equal to 49, our neutrons, which are going to be equal to 73, and our electrons, which will equal to 47. So again, let's determine which element we are working with by looking at our number of protons. Because this is 49, we're going to look for element number 49 on our periodic table, which happens to be indium. So we're going to put our IN over here. Next, we need to determine that upper number. Again, that's going to come from our protons plus our neutrons. So we'll say that our 49 plus 73 is then equal to 122. So now we can fill out more information on our symbol. So we'll put our 122 on top, and the bottom goes our number of protons, which is 49. Now finally, we need to determine if there's a charge to this element. So we're going to look at our protons. Our protons are equal to 49, but that does not equal our number of electrons, which is 47. So what we're going to do to determine what our charge is going to be is we will take our number of protons. Let's do this in red. So protons minus electrons is going to be equal to our charge. So we're going to take our protons, which is 49. We're going to subtract 47, and that is going to be equal to a positive 2. And that becomes our charge. So this 122 over 49 indium actually has a plus 2 charge on it. Now that makes sense since we have more protons and electrons. Again, our protons are positively charged and our electrons are negatively charged. So since we have that higher proton, so more positive than we do negative, we expect our answer to be a positive number at the end. So that will be our final answer. All right, let's do one more example. So in this case, let's say that our protons are equal to 33, our neutrons are equal to 36, and our electrons are equal to 37. So again, let's figure out which element we are working with by looking at our atomic number, our number of protons, which is 33, and that correlates to arsenic, AS. So let's put AS over here. Next, we need to determine our upper number. So since this is arsenic, we're going to put our 33 right there. So to determine that number above 43, we're going to have to take our protons plus our neutrons. So protons plus neutrons. That's going to be 33 plus 36. That is equal to 69. So that will go above our 33. Finally, we need to determine if there is a charge on this element. So looking at our protons and electrons, we see that they're not the same. So our protons equals 33, which does not equal our electrons, who are equal to 37. So because we have a difference, let's go and use our formula again. So we're going to do our protons minus our electrons to give us our charge. So looking at our numbers, we can see that the number of electrons is greater, 37, than it is 33. So we're going to expect that this number will be a negative number. So we're going to take our 33, subtract our 37, that is going to be equal to negative 4. Again, that makes sense because we have more electrons than we do protons. So then our element will have a charge of -4. And that will be our final answer.